Okay guys, so this is our review for your fall semester midterm exam. It's going to cover everything that you've learned from Units 1 up to where you are in Unit 4. So let's just get right to it. Number 1, it says, which is a property of most non-metallic solids? The key word here is non-metallic, meaning non-metal. So there are some properties of nonmetals that you need to know. The first one I was going to say is the answer, and it would be brittleness. But there are other options, such as they don't conduct, they're dull, and they could be solid, liquid, or gas. So those are all options to write down. Number 2, in comparison to an atom of fluorine-19 in the ground state, an atom of carbon-12 in the ground state has. So this question is either going to be about electrons or neutrons. So I'm going to solve for, I suppose, neutrons first. Let me write down these isotopes. So this one has 9 protons and this one has 6 protons. And this number on the top is the mass number, which is protons and neutrons. So you can just do a subtraction of this number minus this number to get the number of neutrons. So for fluorine-19, I see that it has 10 neutrons, and for carbon-12, I can see that it has 6 neutrons. So fluorine-19 has 4 more neutrons than carbon-12. That also leads me to believe that choices 3 and 4 don't make sense. But in terms of valence electrons, I'm going to get that from the group that these guys are in on the periodic table, and I'll write it in blue. Fluorine is in group 17, so it's going to have 7 valence electrons. And carbon is in group 4, so it's going to have 4 valence electrons. So that means fluorine-19 has 3 more valence electrons. But I guess this question says it's in terms of carbon-12. So carbon-12 has 3 fewer valence electrons. Number 3, which element is malleable and can conduct electricity in the solid phase? You're looking for a metal in this case, because those are the properties that metals have. Sulfur is a nonmetal, phosphorus is a nonmetal, iodine's a nonmetal, but tin is a metal. Its symbol is SN if you need help looking for it on the table. All right, number 4, what is the mass number? So you can calculate mass number by doing the number of protons plus the number of neutrons. So what's the mass number of an atom that has 6 protons and 8 neutrons? Electrons don't count here. So 6 plus 8 is 14. Number 5, it says, which set of symbols represents atoms with the valence electrons in the same electron shell? So valence electrons are in the outermost orbital of the atom, which means basically that we're going to be looking for elements that all have the same number of orbitals. Because if they have the same number of orbitals, then that last orbital is the valence shell, and they'll have that valence shell in the same orbital. So, so in any case, we're going to be looking for elements that are all in the same period. If you have the same number of orbitals, then that means you're in the same period on the periodic table. So I'm going to pause the video, and I'm going to get out my periodic table and find the answer for this. So I just found the answer. It's SR, SN, and I, and I found that because they're all in the same period on the periodic table, which means that they have their valence shell in the same place. All right, number 6, which formula represents a nonpolar molecule containing polar covalent bonds? We will eventually be able to answer this one, but for now we haven't gotten to it in the curriculum, so we are not responsible for number 6. Okay, number 7, which changes occur as a cadmium atom becomes a cadmium ion? So cadmium is on the left-hand side of the periodic table. It's element number 48, and it has 2 electrons in its valence shell. So that's why when it becomes its ion, it has a charge of positive 2, because it's just losing those 2 electrons. So in any case, it's losing 2 electrons, so choice 2 and 4 are out. And when it loses 2 electrons, it also loses an orbital. So I just showed the orbitals with the number of electrons they would have for the cadmium atom. But once it loses these last 2 electrons and it becomes positive 2, then the radius is going to decrease because that last orbital is now gone. So choice 1 is the best answer. All right, number 8. Total number of pairs of electrons shared in a molecule of N2. So in a previous lesson, we had learned that when nitrogen bonds to itself, it needs to share 3 electrons with the other nitrogen atom. And nitrogen's in group 15, so it has 5 valence shell electrons. So there were 2 that I haven't accounted for yet. I just put those in for each atom. And basically, it's the 3 electrons in the middle that are going to be forming those 3 covalent bonds. So that there's the 3 covalent bonds, and you would just say 3 pairs of electrons, or for a total of 6 electrons. In number 9, it asks which bond type results when valence electrons are transferred. So the key word is transferred in this question. Transferring electrons only occurs during ionic bonding. So you should definitely have ionic bond and transfer linked in your brain. So ionic bond is the answer. Number 10, which electron configuration represents the electrons in an atom of chlorine in an excited state? So chlorine's configuration is 287 in its ground state. That means that excited state is going to show that one of these electrons has been moved up to an orbital above where it should be. So what I can see right away is that this one looks eligible. And my reasoning for that is it has the same number of electrons. 2 plus 7 plus 8 is 17, and 2 plus 8 plus 7 is 17. So they have the same number of electrons, but this one in number 3 has an electron above where it needs to be. Number 11, which pair of symbols represents a metalloid and a noble gas? So best answer here is choice 2. Arsenic is a metalloid, it borders the staircase, and argon is a noble gas, it's element 18. Based on bond type, which compound has the highest melting point? So you're supposed to know that ionic bonds have very high melting points. And the reason for that is because of the attraction between positive and negative. So in an ionic bond, the positives and negatives are super attracted to each other, so they're going to resist melting and resist boiling. So the next step is you have to choose which of these is ionic. And it's going to be number 2. All right, number 13, the strength of an atom's attraction for electrons in a chemical bond. That's basically the definition for electronegativity. So that's the answer, electronegativity. 14, at STP, an element that is a brittle, solid, poor conductor of heat and electricity. So they're definitely talking about a nonmetal. But the tricky part of this one is that nonmetals can be solid, liquid, or gas. So be careful that when you choose the atomic number for your answer, that it is actually a solid. Of the choices you're given, the only non-metals are 3 and 4. And 4 is number 17, which is chlorine. Chlorine is a gas at STP, so it can't be 4. And 16 is sulfur, and sulfur is a solid at STP. So 3 is your answer. 15, which conclusion is based on the gold foil experiment? This is Rutherford. And he had several conclusions, but the main conclusion was that the atom is mostly empty space. So that's not 2, and it's not 4. The atom's mostly empty space, and that the nucleus is small, positive, and dense. So best answer here is 3. All right, a property of molecular substances. So as opposed to ionic compounds, molecules have very low melting points. So that's going to be choice 3. Okay, number 17. You guys have seen this table before, and they want to know which model correctly describes the locations of protons, electrons in the wave mechanical model. So this is our modern model of the atom. And in the modern model of the atom, we have protons in the nucleus, just like in the previous models, but electrons are going to be in regions of high probability of finding an electron. So I'm thinking the best answer here is B. 18, very straightforward. Which element is a noble gas? That would be krypton. And my backup reasoning is that it's in group 18. Number 19, compared to an atom of phosphorus 31, an atom of sulfur 32, they're being pretty specific about this. 1 less neutron, 1 more neutron, 1 more proton, 1 less proton. So I'm going to actually show my work for this one. Here is phosphorus 31, and here's sulfur 32. Phosphorus has 15 protons. Sulfur has 16. So let's try the proton thing first. They said an atom of sulfur 32 contains, I think I just found the answer, 1 more proton. And if I wanted to prove that it's not 1 and not 2, here's how I would do it. You can calculate neutrons by subtracting the mass number from the atomic number. So just do mass minus atomic. And 31 minus 15 is 16 neutrons for phosphorus 31. And 32 minus 16 is 16 neutrons for sulfur 32. So they have the same number of neutrons, which means that it can't be 1 or 2. Okay, 20 we will get to, but not in time for the midterm, so cross that out. 21, as the elements of group 1 are considered in order of increasing atomic radius. So essentially they're saying you're in group 1 going down the table, because this is where atomic radius is the highest, at the bottom of group 1. So they're actually asking about ionization energy, though, and ionization energy will decrease when the atomic radius increases. Part of the reason for that is that when the protons and electrons are separated by more distance, the strength of attraction between them is going to get lower. So in essence, when you have these atoms with large atomic radii, they're not going to be able to hold on to their electrons well, so the ionization energy would be low. So the ionization energy is lowest down here, and decreases is your best answer. In 22, it asks, which trends are observed when the elements in period 3 are considered in order of increasing atomic number? So period 3 is going to be horizontal, and increasing atomic number is going to go to the right. And as you go to the right, a couple of things are going to happen. The atomic radius is going to decrease because all the elements in period 3 have the 3 orbitals, but the more protons you have, the smaller the radius is going to become. So it's not 2, it's not 4. And as the radius gets smaller, the ionization energy is going to get larger. So the radius is going to shrink, and the ionization energy is going to grow as you go to the right in period 3. And your best answer, I believe, is 3. All right, 23. Based on electronegativity values, which type of elements have the greatest attraction for electrons? So they're essentially asking you for the answer choice that has the highest electronegativity. It's definitely not going to be number 1. Noble gases have 8 electrons in their valence shell, and therefore their electronegativity would be 0. Metals and metalloids are on the left-hand side of the table, so their electronegativities are going to be lower than the nonmetals, which are on the right. All right, Lewis electron dot structures for boron. Boron is in group 13, and elements in group 13 all have 3 electrons in their valence shell, and this diagram shows that. 25. Which element has chemical properties that are most similar to those of calcium? Elements in the same group have the same number of valence electrons and also, as a result, have similar properties. Therefore, I'm going to choose an element that is in the same group as calcium. That could be beryllium, magnesium, strontium, barium, or radium. And strontium is the only answer choice that is in that set. All right, so what happens when an atom of chlorine and an atom of hydrogen become a molecule of hydrogen chloride? So my chlorine atom is going to have 7 electrons in its valence shell, and hydrogen has 1. So what generally happens is hydrogen gives an electron to Cl, and then you have your molecule. They want to know what happens sort of in general when that occurs though, and since stability is increasing, that means that energy is going to be released as potential energy decreases. So I'm going to say a chemical bond is formed and energy is released. Which list of elements from group 2 on the periodic table is arranged in order of increasing atomic radius? So in group 2, one thing you can remember is that as you go down the table, the atomic radius increases. So atomic radius is highest at the bottom of group 2. I would say you're just going to choose a list that goes in order from top to bottom. And I can see that B, E, M, G, C, A goes in that order. 28. Which 2 nuclides are isotopes of the same element? So it has to be the same element, and they have to have different mass numbers in order to meet the definition of isotope. That's going to be number 1. 29. An atom of oxygen is in an excited state. When an electron in this atom moves from the 3rd shell to the 2nd shell, so it's going from a higher orbit to a lower orbit, and as that electron moves down, it's going to release energy as it moves to a lower energy level. So it's going to be emitted. That's going to be the word that matches up with release. So it's not 1, it's not 3. And it's not emitted by the nucleus, it's emitted by the electron as it moves. All right, 30. It says a neutral atom. I don't know if that's going to matter, but it says a neutral atom contains 12 neutrons and 11 electrons. Yeah, it does matter because electrons charge are canceled by protons. So if you have 11 electrons, then a neutral atom would also have 11 protons. So that's going to be choice 2. 31. Which statement concerning elements is true? Choice 1 says all atoms of a given element must have the same mass number. That is false. Otherwise, there would be no such thing as isotopes. 2. Different elements must have different numbers of isotopes. No, that's not true. 2 different elements could have 0 isotope. They could have 1 isotope, 0 isotopes, 2 isotopes, since there's no rule for that. So it's not number 2. Different elements must have different numbers of neutrons. Also false. I think I had an example of sulfur 32 and phosphorus 31. So they could have the same number of neutrons. And lastly, all atoms of a given element must have the same atomic number. That is definitely true. If you're going to be an element, you have to have the same number of protons as other atoms of that element. 32. Which symbol represents a particle that has the same total number of electrons as S2 minus? All right, so sulfur in its atomic state has 16 electrons, just basing that on its number of protons. But S2 minus would have gained 2 extra electrons, so it would have 18 electrons. Meaning, essentially what I'm looking for is the element that also has 18 electrons. And I just checked it out on the periodic table, but choice 2, argon, is element number 18, and therefore it has 18 electrons, so it's going to be the same electron configuration as S2 minus. Okay, and for number 33, this question is about average isotopic mass, which could also be known as atomic mass. And the way we solve for that is we need the percent abundance of each of the isotopes, and we multiply that by the mass of the isotope, and then we just add all those pieces together. So for boron 10, it looks like it's 19.78 out of 100 grams. In other words, that's 19.78%. So I'll do the mass times that abundance. So here's boron 10's mass, and its abundance is 19.78%, so I'm going to write 0.1978. And I'm going to add to that the mass and abundance of the other isotope, which is boron 11. So its mass is 11, and its abundance is, it looks like 80.22 out of 100, so that's 80.22%, 0.8022. And we don't have to actually solve it, we just need to choose the correct setup. And, oh, I do have a small correction here. For boron 10, it gave me a mass of 10.01, so I'm going to change this to 10.01 and 0.1978. And for boron 11, it gave me a different mass as well. It says that it's 11.01. I think that they're accounting for the mass of electrons here, so I think that's why it was a little bit more than we expected. But I'm going to look for 10.01 by 0.1978, which could be choice 3, except that it has a division sign, so it's not 3. And that means it has to be choice 2. All right, so that is the whole review sheet. Here are the answers if you just need to check.